Perfect. So let's move on to the next organ, which is the pharynx. So all this is the pharynx. And the main thing that we're going to look at here, what occurs in the pharynx, is when we push food into the pharynx, it's going to start the swallowing reflex, or known as deglutition. All right? So what's going to happen here, let's go to the next picture here, is food is chewed and mixed with saliva, all right, and that creates the bolus. All right, and then what we're going to do next is the tongue is going to push that bolus to the pharynx, and that's going to activate the swallowing reflex. All right, so when this occurs, our tongue is going to block off the oral cavity. All right, the soft palate and uvula get moved up, and that's going to block off the nasopharynx and the nasal cavity. All right, the larynx actually rises up. And so when it rises up, it gets that epiglottis to move over, and so that then diverts food to the esophagus, okay? So once we get food to the esophagus, then peristaltic contractions are going to move it down the esophagus. And so those are the steps in deglutition or swallowing. So once we get to the esophagus, I don't have any great pictures of the esophagus by itself, but the esophagus is between the pharynx and the stomach. So this is showing the end of the esophagus. You know, the previous picture there showed the beginning of the esophagus. So our esophagus is actually collapsed when it's not involved in food propulsion. So it's not open all the time like our trachea. Peristaltic contractions are going to move the bolus down the esophagus. And at the end of the esophagus is what is known as the lower esophageal sphincter, also known as a cardiac sphincter. So this is made of circular fibers there, all right, of the esophagus, and also the diaphragm. So what's not seen here is our diaphragm moves across in this area, all right, and our diaphragm is going to be helpful in closing that sphincter. So this closes the entrance to the stomach, but more importantly, it prevents the regurgitation of stomach contents back into the esophagus. Because if stomach contents get moved up here, now if you remember here, our stomach produces hydrochloric acid. We're going to talk about that in a minute. And the stomach lining is such that it can deal with that acidity. Now our esophagus does not have that lining. So if any stomach contents gets regurgitated into the esophagus, we're going to feel this burning sensation, and that's what is known as heartburn. Because literally our heart is right here in that area. It's above the esophagus. Okay? So some people can have a gastroesophageal reflex disease, or known as Gerd. That's where acidic gastric juice regurgitates into the esophagus. That's what causes the heartburn. Some people can also have what is known as a hiatal hernia. And that's where the stomach protrudes above the diaphragm. All right, so if the diaphragm is here and the stomach's pushing into it, that weakens the diaphragm's ability to help close that lower esophageal sphincter, and this allows gastric juice to move back up into the esophagus. All right, so let's move on to the stomach. Our stomach, as you can see, all this is a stomach. This is a storage tank of food where chemical breakdown of proteins actually begins. Its capacity is about 1 liter, but you can stretch this up to 4 liters, so about a gallon. All right, let's take a look at the microscopic anatomy. So this is looking at gastric glands right here. All right, the gastric glands produce gastric juices. All right, and so those gastric juices are made of a variety of secretions from these glands. So first looking at parietal cells, kind of these purplish bluish cells there. These are going to secrete hydrochloric acid. And that hydrochloric acid, the main reason that we produce hydrochloric acid in our stomach is to kill microorganisms that we might have ingested. Okay? And also, to a slight degree, helps break down the food, but that's not what's important here. These parietal cells also secrete what is known as intrinsic factor. Now, intrinsic factor helps our small intestine absorb vitamin B12. Okay? So by doing that, we can absorb that vitamin B12, which is necessary for making DNA, which is necessary for all of our cells. Okay? Next are chief cells. So if we look on this picture, these reddish cells there are the chief cells. These are going to secrete digestive enzymes, particularly pepsinogen. Now, pepsinogen gets released into our stomach, and it interacts with the hydrochloric acid to become pepsin. And pepsin is a protein that breaks down, pepsin is an enzyme that breaks down proteins. So that's what it does. Next are enteric cells. So on here, these yellow cells are trying to show those enteric cells. These are going to release hormones. They're going to release histamine, cause some more blood flow to go to the stomach, endorphins and serotonin, so those are kind of the feel-good ones, and also gastrin, which regulates stomach secretions and motility. So causing more stomach secretions, causing our stomach to move so we can move stuff, either churning the stomach or moving stuff out of the stomach. Next are mucous neck cells. So those are up here, these kind of orangish ones as well, I don't know. These are going to secrete mucus. Now the mucus that is secreted here is very viscous and it's alkaline or basic in nature. And that's going to help protect the stomach lining. All right, let's look at gastric secretions. All right, and so we have these different phases in which we produce gastric secretions. So the first phase is called the cephalic phase. Now, cephalic refers to the head. All right, so these are secretions. These secretions are released when food is seen, or smelled, or tasted, or even thought about. We'll start producing gastric secretions here. So it's basically getting the stomach ready for food to be delivered there. Next is the gastric phase. So the gastric phase is referring to the stomach itself. So this starts when food reaches the stomach. And so we're going to release even more gastric secretions because we have food there now. All right. The next phase is the intestinal phase. And this begins when food leaves the stomach. So our small intestine is going to secrete hormones that are going to actually inhibit gastric juice secretion. All right. So if there's no food in the stomach, we don't need to continue producing those secretions. All right. Let's look at gastric absorption. So what we absorb out of our stomach is not a whole lot. Our small intestine is our major absorptive organ. So what we absorb here is water, some salts, lipid-soluble drugs like aspirin, and alcohol. And this is one of the reasons why you shouldn't drink alcohol on an empty stomach, because you're going to start absorbing that alcohol very quickly. Next is the mixing and emptying movements here. So we're going to use mixing movements in our stomach, very similar to segmentation, contracting one area in other areas, and that's going to move the food back and forth with the gastric juices. So this is going to produce a different kind of substance that we now call chyme. So we called it the food substance bolus when it was in our mouth, pharynx, and esophagus. In our stomach, we now call this chyme. All right? So this is a semi-fluid paste of food particles, and it's made the stomach. Then that chyme is moved out of the stomach by peristaltic contractions.